Go ahead. Hi, everybody. My name is Jason Morris. I'm the CEO of Lexpedite Legal Technology, and I'm currently engaged as the Director of Rules as Code for the Public Health Agency of Canada. And that's my email address, and I would like very much to hear from anyone here today about any of this or anything else. I've just been fascinated with everything. So I'm going to be talking about Blawx. Blawx is user-friendly something for rules as code. And the background is that I've been working on Blawx since the start of 2021 with a group at the Canada School of Public Service. And that is a central agency in the federal government of Canada. That's kind of like the internal learning and teaching department. And they have a subsection called PSX, Public Sector Experimentation. And that group has been doing rules as code experiments for quite a few years at this point. And I've been helping them since 2021. And as soon as I joined in, I started redeveloping the Blawx software for their purposes. And what they're aiming at is rules as code in the public sector administration sense, which is using semantic representations of the meanings of laws and regulations in order to help at every part of the policy lifecycle. So from policy design to regulatory drafting to systems implementation to static analysis after the fact, and implementation like compliance by private actors who are regulated entities and the whole thing. So there's a lot of variety there. I've been trying to develop Blawx as a way to get subject matter experts who are not programmers involved in both writing the code and reading it and validating it and testing it as much as possible. And so it's a prototype, still early days, but we're kind of making good progress. It's currently being used in 2 projects inside CSPS, one of which is a systems administration project. Another one is a legislative drafting project. And there's a couple more projects that we're expecting to onboard in the next couple of months. We've only been using it with actual non-programmers writing the Blawx encodings since about August. So it's very early days, but I'm happy with the progress so far. It uses Blockly, which is a Google library to do the user interface. And that's a tool for educating children on how to write code. So if it works for kids, maybe it'll work for lawyers, is the thinking. And I can say that because I am a lawyer. And it uses CASP, which you've already heard about today, as its reasoning language in the back end. So the process of using Blawx is in 4 stages. You give Blawx the legislative text, then you encode the legislative text section by section, and that encoding involves 2 parts, the first part being the ontology and the second part being the rules. Once you have done that, you go through the process of validating your encoding, which is really right now where we're getting where the subject matter experts are getting involved. And then you deploy your encoding for whatever it is that you were trying to do. And ironically, in the legislative drafting process, a lot of what you were trying to do is actually learn the things that come from trying to encode it. So there may not be a step 4 in the legislative drafting process, but often you're trying to build a piece of software, or you're trying to do some systems simulation, or you're trying to automate something. So that would happen in stage 4. So I'm just going to show you the current system, and I'll just get someone to confirm for me that you can see this on the screen, the Blawx website. Oh, it looks like it's there. Okay. Let me know if there's any problems. So I'm going to show you the Old Age Security Act test, which is the example that was used in the paper that was just this morning uploaded to the website. So you can take a look at the PDF later if you'd like. So step 1 is getting the rules, the legislation in. For that purpose, I've created a markdown-like syntax. It's called CLEAN, Canadian Legal Enactments in Acomo and Toso. So this is basically a markdown-like syntax that generates Acomo and Toso in the background. And so you just type it in a plain text. This is not as user-friendly as I would like it to be, but it's a lot more user-friendly than trying to write Acomo and Toso. So good enough for now. So you do that, and you've got the text of the act in there with its structure. And then you go into the code editor, and the structure of your text becomes the structure of your code. So you can see that the text of the law gets converted into a nested tree of sections. And if you have need, you can use clean to add arbitrary additional sections in here wherever you want them. And then the idea is that you can go section by section, encoding the semantic meaning of each part of the law in the Blawx language on the right there. And there was some talk about structural isomorphism before. This is an example of wanting to keep the smallest possible section of legal text and have a one-to-one relationship with the smallest possible section of code. The advantage being it's easier to review, it's easier to change when the rules change, but this is also a very familiar interface for people who are used to dealing with the legislation itself. So today we're just going to take a look at section 3.1a, which is subject to this act and the regulations. A full monthly pension may be paid to every person who was a pensioner on July 1st, 1977. And so I said there are two parts. You can see the two parts are represented in these two blocks. The first one sets out the vocabulary for this section. So there is a category called person, and a person has attributes pensioner July, which is a true or false attribute, and it appears as it is true or false that the person was a pensioner on July 1st, 1977. So you define categories and then attributes, and then you give those attributes a natural language representation. So if we wanted to say that a person had an attribute was called best friend, we would just drag this in here and say best friend, and best friend is a person. And then we could copy this block and say, we're going to say the target person is object's best friend. And then if we save that, you can see that this has created in the user interface a new block that's available here. And so the actual coding happens in the natural language and in the blocks. The natural language makes it a little easier to read and maybe a little easier to write, hard to know. And then the fact that it is in natural language makes it easier to read for people who aren't writing the code. But that natural language also gets used by CASP in the explanations. So you can see the second part here is encoding the rules. And here what we said, if there is a person and that person was a pensioner on July 1st, 1977, then we know according to this section of the Act that the person qualifies under section 3.1a. And that conclusion is being used elsewhere to conclude whether or not they're entitled to a pension. So that's the basic idea. Step 2, you encode the vocabulary and you encode the rule, and you've got this nice little block format that will not allow you to put things where they don't belong. So a data type like time will fit up here, but you can't put it in there. It just clicks away. So that's how that works. And then you want to validate. Now I usually go section by section and validate each section as I'm going. We'll skip that process and skip to a more generic validation in the interests of time. So this is a test for the generic question of does it legally hold that the person is eligible for a full monthly pension or not? Both the true and false, eligible, and the person are variables. So that's your question. And then you've got the scenario editor, which is we've made a bunch of changes to this just in the last 2 weeks to kind of minimize the things that are displayed. So we've got this view feature now that allows you to exclude attributes that are not going to be useful to the user, and even sub-attributes of specific objects, if that's helpful. So we can see we've got the category person here. We can add a person, let's say Jason, and we know that whether or not I was a pensioner in July of 77 is what's relevant in 3.1a. We can say that that's true. We can say that that's false. And then we can run the code with those facts. We can also get rid of this, and we can use this unlock button to say that SCASP can create an abducible predicate here for whether it's true or not that Jason was a pensioner in July, and reason hypothetically about it. So now that we've created those facts, we click run, And this is going to take a few seconds for a couple of reasons. One, I've discovered the way that I've implemented diffusibility is computationally inefficient. And so I'm going to be coming back to that in the next few months to see if I can speed that up. But also, this is alpha software, and I'm a lawyer, not a programmer. So I need everyone to keep their expectations quite low. Is that enough stalling? Is it going to give me an answer? There we go. So we get 2 answers back. And remember, the question was 2 variables, the person and their eligibility. So we've got 2 answers, one where I'm the person and eligibility is true, and one where I'm the person and eligibility is false. And then it will give you as many explanations as it finds. Those explanations are in natural language, and they are linked back to the text of the original act that was used in the reasoning. And you can see here it says that it has abduced that Jason was a pensioner on this date. And so it's assuming that that was true, then yes, Jason is entitled. And then over here, you can see assuming that the same thing is false, then it is false that Jason is entitled. So if that is the only variable that you're making available to the reasoner, it can find a way of getting both a true answer and a false answer with regard to Jason. And because this is using a predicate type of logic, it's different from tools like DataLex, where you really can only deal with one entity of each type at a time. Here you can ask the question about as many people as you want, and the reasoner is perfectly happy. In an expert system, what you would like to know is what's relevant to the conclusion that you're seeking. And Blawx has the scenario editor here has a little demonstration of that, in that if you set something to possibly true, possibly false, and then run the query, and it turns out that that element was in fact relevant in one of the explanations, then it will show up as highlighted in the user interface to let you know this is a thing to which a concrete answer would give you a concrete, or a concrete input would give you a concrete answer after the fact. So that's kind of where we're at. It's available at dev.blawx.com right now. In fact, this code I think is publicly available, so you can try this actual interface yourself. And I would absolutely love to get any kind of feedback or questions from the people here today. And I think that's my time.